Okay, so starting from paper 2 question. So this is, let's suppose, our first question for practice related to electricity. And the first question is related to the resistance of a wire that is actually connected with a EMF of 8 volt. So EMF of the battery is 8 volt and the length of the resistance of the wire is shown in the diagram. And the power dissipated by the resistance wire is 36 volt. You know the concept of power dissipation because when current passes through the wire, so always there will be a quantity of resistance over there. So due to that resistance, some power is going to be lost in the heating effect. Now, first of all, we need to calculate the current in the resistance wire. I hope that is very simple one. This is the value of power.
Yeah,
Yes,
yeah. So power equals to VI. So if we're gonna find out I, what we're gonna do is we're gonna do P divided by V, which
yes.
is gonna be 36 divided by 8, giving you 4 amperes.
So this is a very simple one and SI unit is mentioned over there. So 4 ampere is the value of electric current. Round of value. Okay. And the next part is the number of free electrons that passes through the resistance wire in a time of 50 seconds. So there is a value of time, 50 seconds, and you need to calculate the number of free electrons that passes through the resistance wire in the time of 50 seconds. So any idea how to calculate number of electrons? The values that we already have in our previous part, maybe that will help you. Okay, in short, if we talk about free electrons, so free electrons in simple words, we can say that you need to calculate the number of charges.
Okay.
Now, any
Okay.
idea how to find this one?
Using the Q equals to I over no, I equals to Q over T.
Yes.
So they gave us T 50 seconds and Q, we're gonna find out an I is 4. So 4 equals to like Q over 50. So then we're gonna do 50 multiplied by 4. You're gonna get 200.
Okay, so first we multiply a Q. Sorry, the value multiply 50 into 4, we will get the value of number of charges, right?
Yeah. And then you're gonna, I think,
Yes. Now we need to
you
divide it by,
oh, you gotta divide it by 1
yes,
point.
1.6 exponent minus 19, that is the charge of electron.
Okay.
So number of electrons then 200 divided by 1.6 and minus 19. So this will
Let
give
me
you the
count.
final answer. This is
Okay, the
4.5.
answer is gonna be 1 point. It's gonna, oh, okay, got it. So that 225 divided by 1.6 times 10 to the power of negative 19. You're gonna get 1.4 times 10 to the power of 21.
Okay. So these are the number of free electrons. Now, the next part is you need to calculate the resistance of the wire.
So resistance equals so V equals to IR
Okay.
and R equals to V divided by I, right?
Okay. So it means that we again need to use the formula of E is equals to IR, the
Yeah.
Ohm's law. You can see that from your past
Plus
paper, most of the questions are like the same pattern of IGCSE.
step by step.
Yes. So voltage is 8, I think,
8.
yes.
Yeah, and I is 4.5. So 8 divided by 4.5 gives you 1.78, or you can just round it to 1.8 ohms.
Okay, so these are 2, 4, 6, 3, 6 marks from this question. Next is the metal of the resistance wire in the circuit has a resistivity of 1.4 exponent minus 6. This is the value of resistivity. Next, we have the cross-sectional area of the wire is 0.25 millimeter square. Determine the length of the wire. So resistivity is given, length is given. So how to calculate the length of the wire? Sorry, length is not given, cross-sectional area is given. Actually, the symbol for resistivity is that raw symbol in the formula. If you remember that formula, R is equals to
Or
this one.
wait, I forgot. I remember studying it though.
Yes, actually
Yes.
this formula is that formula related with the factor affecting resistor, right? Resistance is directly to the length and inversely to the cross-sectional area, right?
Yeah.
So this is the formula and that will help you to find out the value of length because we already have value of cross-sectional area and resistance we already calculated 1.8. Resistivity is also given. So simply we need to do A divided by resistivity is equals to length.
Wait, where'd you get the 1.8? Oh, okay, so it's the resistance. Okay, resistance multiplied by
Now
0.25.
cross-sectional area is 0.25 millimeter square. So
Mm-hmm.
we need to convert this milli into simple meter square
Okay, so you're gonna multiply it by like 10 to the power of
minus 3 or something else.
minus.
Because if we just write millimeter, right? Let's suppose if we only consider the value of millimeter, so it will be to the power minus 3 meter, but it is millimeter square because you know that in area we actually use two dimensions. So two dimension means we need to
It's gonna
convert
be
it.
squared.
Yes,
So it's gonna be 1,000 squared, is the difference.
this
So
minus
it's
3
gonna be
square, so 2 3s are
3
6.
plus 6. So
Yes,
so 0.25 times 10 to the power of negative 6, and then you're gonna divide the whole thing by 1.4 times 10 to the power of negative 6.
yes,
They're both to the power of negative 6, but they're doing that because you need to use meters, right?
yes, because we need to convert into meter because resistivity symbol contains ohm meter and we need to calculate the length in SI units, so that's why we need to convert this millimeter square.
Okay.
So what is
Let
the
me
final answer you are getting? Minus
wait,
6 minus 6 will cancel out each other.
you get 9 over 28, so 0.32.
Okay.
And
So
it's gonna
0.
be meters, right?
Yes,
0.32
meter.
meters.
Yes, because in AS you already got your SI units in your answer, so you need to convert according to that. So there will be no confusion that either we need
Yep.
to convert or not because units are already mentioned. Now they ask next part. The circuit shown in figure 6.1 is modified by replacing the original resistance wire with a second resistance wire. So now we are having a new wire and the second wire has a greater diameter, greater greater cross-sectional area, and then the original wire. There are no other differences between the second wire and the original one. So it means there is only a
Okay.
change in cross-sectional area by reference to the resistance. State and explain whether the power dissipated by the second wire is more, less
So when
than,
the
or the same.
diameter is greater, that
Yes,
means that the whole cross-sectional area is greater, meaning that the resistance, because it's inversely proportional to the resistance, right? So if cross-sectional area gets more, that
yes,
means resistance will get less.
yes.
So the power dissipated by the second wire is
Hmm.
gonna be, I want to say, more
Okay. So the
than.
first concept that you need to write is related to the resistance and cross-sectional area. So longer cross-sectional or the larger cross-sectional area has less resistance, right?
Yeah.
Increasing the diameter will decrease,
The resistance.
yes, will decrease the resistance. And the second thing you need to write for the power dissipation. So what will be the value of power dissipation? It will remain same or less or equal. So we know that in this situation, potential difference remains same, but we are getting more value of electric current, right?
Okay.
Remains the value of electric current will increase.
When I'm writing my answer, do I have to like I can write just current. I don't have to write electric current, do I?
Yes, but we are just starting our questions. So we are actually discussing all concepts that will help you in next questions. So that's why we are writing in detail. But for your answer, it is not compulsory to write about the current, but that will give you the reference because when we use the formula P is equals to VI, so P is equals to VI means V remains constant, but if the value of current increases, it means the value of power dissipated will also increase. So that will help you to link your formula and answer your question related to the power dissipation.
Okay.
So more power dissipated, the answer of this part, right? Actually,
Yep.
we take reference from this formula, right? P is equals to VI.
Wait, can I write the answer?
I will send this solved PDF file to you after the class, right?
Okay, yeah.
Okay, part D, the circuit shown in figure 6.1 is modified again by connecting a second battery of EMF 8 volt. So now we are having another uh, that is connected with the circuit because we are having a second battery and negligible internal resistance. So it means we need to ignore the internal resistance in parallel with the original battery and the original resistance wire. Okay, so wire remains same, connection remains same, only one and other source is connected with the previous one. So 8 plus 8 is over. By reference to the current in the resistance wire, state and explain whether the addition of second battery causes the power in the original resistance wire to decrease, increase, or remain same. So now they are talking about,
But so
yes,
when you add the second battery, is the voltage gonna like overall increase?
okay,
And P equals to VI, so if V increases, that means the power will also increase, right?
okay. So
But
basically, in this, it actually what we do, we just connect two power source, two batteries over there, and both are in parallel combination, right?
yeah. So
So
it's not gonna be affected. Like the second one's not like the original wire won't be affected, I think.
okay, so it means that what will be the effect of current on the wire? If we talk about the current, the voltage through the wire, so is there any effect on that or not?
Isn't the current like different in like parallel circuits? Current isn't same everywhere.
Yes, so we know that voltage will remain same, right? So that is definitely the understood thing, because voltage is actually remain same in the parallel combination. So circuit is in parallel combination, so voltage remains same, right?
Mm-hmm.
And if we talk about the electric current, so electric current actually divides, right?
Okay.
And electric current actually divides means that current will pass from this source to the wire, and then through the wire till the negative terminal of the battery. Okay. So
Okay.
electric current will remain same or will it vary? Because in parallel combination, we know electric current actually divides or splits according to the components. But in this situation,
Yeah.
battery is connected above the original one. So it means wire is still connected with the previous battery with the same combination, right?
Yeah.
So it means that current in the wire again remains the same, because that battery is not affecting that wire, because wire is still connected with the previous
Right.
battery with the previous pattern, right? So if current
Yep.
divides, so there is no other component connected in the circuit. So it means that no current change in the circuit because no additional component connected. So current will also remains the same.
Okay.
In
So the
parallel,
power.
yes,
So if the current is same and the voltage is same, that means that the power will stay the same.
also same, yes. So again, you need to write with the reference that voltage will remain same, and just mention that current in the wire remains same and potential difference across the wire, because we are only talking about that wire. Okay,
Okay.
because if you just write the voltage, so it makes sense like we are talking about the whole circuit, right?
Yep. Yep.
So it will remain same, current will remain. So finally you are getting the same value of power dissipation throughout the wire. Okay, so this is the concept. And this question of 12 mark, that is from February 22, and I think it is the easy question because most are related to the formula of power and Ohm's law. Okay.
Okay. So it's pretty simple, like the electric chapter in
Yes,
physics.
sometimes you get very simple and basic question from electricity because you already study electricity in very detail in your IGCSE, but in waves there are uh, new concepts like superposition, interference, phase angle, polarization. So that's why that part is slightly difficult as compared to electricity, right?
Yeah.
Okay, same year, that is winter 22, question paper 2, variant 2. This is related to internal resistance because this is our new concept. So might be this question takes time and maybe it will be trickier. So if we start from the first part, so again, we are having a basic definition first. So you need to define potential difference first on 1 mark.
Potential difference is the energy which is transferred from one end of the terminal to the other.
And also you need to mention unit charge per unit charge, energy transferred per unit charge from electrical to the other form or from one terminal to the other, right? Throughout the circuit.
Yep.
So you already know the definition, so we are not writing in detail again and again. Part B, a battery is connected two resistors X and Y shown in figure, the resistance of X is greater than the resistance of Y. X is greater than resistance of Y. State and explain which resistor dissipates more power. So think about the connection and then try to answer.
So this is basically like the potential divider because it's two resistors connected in series, right? So
Okay,
if resistor X has a greater resistance than resistor Y, we did this the other day.
okay. So it means that both are connected in series combinations. So it means that
Yeah,
we are getting same electric current, right?
yes, but then the voltage would be different.
Voltage will be different. Okay, so
And
that's
VI, so if resistor X,
yes.
basically resistance V equals to IR. So
o-
when I is constant, right? V is directly proportional to R.
Okay, okay. We can do one more thing. Let's suppose if we just mark symbol Rx, resistance
Yeah,
of resistor X, and Y for Ry, resistance of resistance Y. So we can say that Rx is greater than Ry, right? And there are three different variation of the formula of power. So we can use the variation form of P is equals to I square R, right? So first of all, we need to write because question is of 3 mark. So we need to mention each and everything. So same value of electric current, same or equal value of electric current in X and Y. So this is our first point. And the second one is we need to use the reference from the formula of power, that is from P is equals to I square R, right? Because in power dissipation, we discussed that the basic formula of power is equals to VI. But if we just replace V with the reference of IR by using Ohm's law, so new formula will be equal to P is equals to I square R, right? Because in this question, we can take the reference from electric current, and by using the electric current, the resistance and the electric current gives you the value of power dissipation, right?
yeah,
But the
yeah.
problem is this, we use this formula, but resistance of both resistors are not equal. Rx is greater than Ry. So now what do you think? Which
So power
resistor
in
will?
R
Hmm,
is gonna be greater than the power in RY.
yes, because we know voltage remains same. So it means that voltage remains same for, sorry, voltage actually divides for X and Y, but we are not having any value of voltage and any reference of voltage. So that's why we just take the reference from current and resistance, because that also gives you the value of power dissipation. So power, or we can say that resistor X, more power, right? So these are the three key points from of your answer by using which you need to answer your question. First, you gave the reference of current, then the formula related to current and resistance, and the final statement about that X is greater or Y is greater, right?
Yeah.
Okay, this one is the
Are there any questions where they ask you to derive the formula?
yes, they asked the question, maybe we will found in some papers, because there are questions. I don't remember exactly in which years they asked, but they ask about the derivations. Okay.
Okay.
If you just find out from your recent past papers, just year by year, so somewhere you find the derivation, maybe in some question during the class we will found that. Okay,
Okay. Okay.
but still there is a concept, because in your SLOs of syllabus it is mentioned that you need to know how to drive the equation. So let's suppose in this part C, a battery of EMF 9 volt is connected and internal resistance R, that is a small r, is connected to two resistor P and Q as shown in figure, and some values are mentioned 4.5 ampere. And what is the question? A total charge of 650 coulomb moves through the resistor P in a time interval of 540 seconds. So this is only for P. During this time, resistor P dissipates 4800 joules energy. So, so many quantities are given. Next part is the current in the resistor Q is 4.5 ampere. Assume that the EMF of the battery remains constant. This is important point. Calculate the current in resistor P. So first of all, we know that the charges for resistor P is given, right? So these are the charges that are passing through resistor P. Okay. So we know that charges are given, so we can easily use the formula of I equals to Q over T. Okay.
Yeah.
If we
Okay, can
just
you
take
go
the numbers.
back up to the diagram? So it's resistor Q. Okay, so they're in a parallel circuit. So they're
Yes.
gonna have the same voltage, but they're see the current for Q is 4.5. And what was the total current? Like,
Actually, total current is not mentioned anywhere in the question, not in the diagram too, because we need to find out the current through P. So if they mention the value, so we can just simply subtract from the 4.5 and we will get the answer.
well, if we find out total current and then we can subtract it, can't we do that?
Okay. You may also do that. But we know that time is given and charges are given. So is it
Yeah.
easy to find out the answer?
Yeah.
Because 650 is the coulomb charge, time is 540. So you will simply get answer that will be equal to 650 divided by 540, 1.2. Okay.
Okay.
So it means that we are getting a current of 1.2. Let's mark over here. Now the next part is the potential difference across resistor P. So one more thing, that the during this time the resistor P dissipates 4800 joules of energy.
Yeah.
So this is
So
also for P.
energy equals to
Hmm.
VIT, right?
Okay.
And so V, and if we want to find out potential difference is basically the volts, right? So V equals to energy divided by I multiplied by T. So
Okay.
energy is 4800, and we're gonna divide that by 1.2 multiplied by
Hmm.
540.
Okay.
And that's gonna give you, I think that's how you do it.
Okay. So you use this right concept that you know that E is equals to VIT, then we know the basic formula of voltage, or you may just use the reference of the voltage from the definition that work done on a unit charge or energy transfer. So that will be
And
also
that's
like W over Q, 7 point.
7.4.
Yes, that was the right one. Or you may also use the same formula from the definition, because one variation of the answer you already know with the help of energy formula and with the help of this voltage formula. But if you just simply take the formula from the definition, work done on a unit charge, so work done is actually equal to that energy, right?
Yeah.
That was given in the question, 4800.
Divided by
Yes.
this.
So that will also give you the same answer.
Do they accept both workings though?
Yes. This will also works for you, or otherwise you use the two different equations to find the value of V. Okay. Because both will make the same sense, because the SI unit of work is joules and we know that energy is the ability to do work, right? and there is no special quantity that actually connects with the energy and work done, right? If we
Yep.
calculate the value of power, so in power we need to divide the quantity by time. So that's why that was a different thing, right?
Yep.
Because, during the definitions and the basic concept of potential difference and EMF, we use this concept of V is equals to W upon Q, because this is the basic formula for potential difference, right? Rather than that Ohm's law. So one
Yeah.
variation you already got, you already solved by that formula, so that is also acceptable, and this is also acceptable, right? So
Yep.
if you want, you may solve from that one or this one. Both are the right one. And the final thing is you need to calculate the internal resistance R of the battery. So we need to calculate the internal resistance and the current in the
That
Q.
you right? It's that they even have like the box which you mentioned before, like the shaded.
Yes. So that dotted box gives you the concept of internal resistance. So for internal resistance, what we need to find.
We need to know the
Mhm. Okay, now
wait, I'm
let's
gonna check my
consider.
notes.
Okay. Okay, if you just check the combination first, right? So internal resistance and Q, right? If we consider the
Yeah,
value
yeah,
of
yeah.
Q
It,
and the value of electric current, because if you remember when we are solving that Kirchhoff's, I think second law question, so we also used to do the
yeah.
same thing. So when current starts to pass from this direction, so Q and R like in the series, so same current will pass through the circuit. Okay.
Okay.
So 4.5 is passing through the Q. It means that the same current actually passes through uh, from the last time from this side, that is through the R. Okay. So it means that 4.5 is the value of electric current. And next, we are having value of electric current through P, that is 1.2, right? And then we are having a value of 4.5. So actually there are two values of electric current. One is 1.2 and the second one is 4.5. We know that when all current divides from this point, from this branch, so current actually divides into two parts, this part and this one, right?
Yeah.
And when these charges will meet at the second branch, so they will again combine and moves in the same direction, right? So it means that we need to add 5 plus 0.2. So we are getting a combined current through internal resistance, right? Because
Yep.
current between P and Q actually divides, but the original value of current remains same. So we first write that the total value of electric current is equals to 4.5 plus 1.2. That will give you 5.7. So this is the total value of electric current. And we know that the EMF is actually equals to 9 volt. And if you remember that formula, E is equals to IR plus.
I R, but like it's gonna be I, and then in brackets it's gonna be R, like the capital R, the small R. So the small R is for the internal, and then the big R is for the load.
Okay. So now what we need to do, that E is equals to, it is the value of the EMF into IR plus the potential difference that we get, because potential difference remains same throughout the circuit, right? So if we calculate the potential difference across P, that is 7.4. So it will also remains the same for the next resistor, that is Q, because in parallel combination, the potential difference remains the same. Okay. And we know that with the help of potential difference, why I am giving, because we know that it is equals to I capital R, right? And in short,
Yeah.
we can say that this IR is equals to V. So if you want, you just solve with the reference of IR. For that, you need to add the resistance first. You need to combine the current. So that is a lengthy part. So we just take the reference that we already calculate the potential difference, and potential difference remains same in parallel combination. It will remain same in parallel combination. And we know that it is equals to IR. So we don't need to calculate the value again. We just use the reference from that 7.4. So this final equation will actually equals to 9.0 the total EMF, I into R plus 7.4, right? Now it is very simple
Yeah.
because question is of only 2 marks, so we don't need to just solve again and again for two or by using two or three equations. So just take it very simple. And finally, 9 minus 7.4 is equals to IR. The value of total current we already calculated, 5.7.
So 1.6 equals to IR.
1.6 divided by, that is the value of internal resistance, right?
Yeah. That's gonna be 0.28.
Something 0.28. Or we can round it off to 0.3 or just write 0.28
Don't
because
you
two
need like two?
significant figure. Two
Yeah.
significant, so it's 2.8. Oh, sorry, 0.28, right?